Alright guys, now let's look at the rules of naming organic compound. Now we're going to, in this particular video, we're going to be looking at the first two rules. We're going to be concentrating on the first two rules. And rule number one says that what? Identify the longest carbon chain. Identify what? The longest carbon chain. So anytime you see an organic compound structure, the first thing you should do in order to know the name is to what? Identify the longest carbon chains, followed by you number the carbon chain, which we call the parent chain. You number it close to any substituent available in the compound. Do you understand? Now let's put this into practical. Okay, now can you see the structure? This is an organic compound. Now we don't know the name. We don't know the name. Can you see this? But how do we now give this organic compound its name? The first thing you will do is what? Identify the longest carbon chain. Now let us look at this. If you want to identify, we can count from here. This can be 1, 2, 3, 4, 5. Okay. Another way we can number from 1, 2, 3, 4, 5, 6. Do you see that? Let me bring this one down so that it won't confuse you. 1, 2. Now let's number from the end to the beginning. 1, 2, 3, 4, 5, 6. Okay, you can see that we've numbered in different forms. That's what you're going to do first. So which one is the best? Which one is the longest? That's what we want to look at. When we numbered from here, we have 1, 2, 3, 4, 5. This is 5 carbon chains. When we numbered from here, we have 1, 2, 3, 4, 5, 6. And when we number from the end to the beginning, we have 1, 2, 3, 4, 5, 6. Do you see that? So we have 2 longest chain. Do you see that now? So which one is the best to pick? Which one is the best to pick? We can either pick this or this, from the beginning to the end or from the end to the beginning. But how do we know the best to pick? That brings us to rule number 2. Do you remember the rule number 2? You are going to number close to the substituents available in the compound. Now, when we talk about substituents, they are like attachments. CH3 here is a substituent. It's attached to this carbon chain. H is not a substituent, it's the tetravalency of carbon. Do you understand? It works with the tetravalency of carbon. But this is a substituent, an attached group, an attached radical, an attached group of atoms. Do you understand? And this is another one. Bonds. This is double bond. This is double bond. Can you see that? If you have double bond, triple bond, that is also a substituent. Do you understand? So in this, we have 2 substituents, but let us concentrate on this double bond. Because whenever you have double bond and you have something like this is methyl. This double bond is stronger than this methyl. Okay, I'm not going to concentrate on that, but let us take this as the main substituent. It means we are going to number close to it, which means this one, 1, 2, 3, 4, 5, 6, this is what we are going to pick. Are you getting it now? Okay, in order not to make this too long, we are picking this one, so I'm going to clean every other numbering to avoid confusion. Okay, can you see that now? So we are picking this one from the end to the beginning, because this shows that this carbon that is holding this double bond is number 1. That is what that rule number 2 means, that number the carbon, the parent chain, according to number it close to the what? to the substituent in the organic compound. So this is the substituent. So number 1 has the double bond. That makes sense. Now you're saying that numbering from here to here, and we are saying that the one that has the double bond is number 6. No, that's wrong. It has to carry the lowest number. Do you understand? Or the lower number. So this is number 1. That makes sense. Okay. So now from here, when we now know that we have 6 carbons in this chain, that makes it what? From your prefixes. From your prefixes for numbering, we have di. We don't use mono. We know mono is 1. We don't use mono. But we start from di, tri, tetra, and so on and so forth. I don't want to talk about that. I want to believe that you know that already. Okay. So from here, we have 1, 2, 3, 4, 5, 6. So your parent, what's it called? Your families in your homologous series. Do you still remember that? We have the alkane family, we have the alkene family, we have the alkyne family, we have the alcohol family, we have the alkanal family, we have the alkanoic acid family, and so on. Do you understand? But looking at this, it has a double bond. This is not alkane family. What family of the organic compound has double bond? Thank you. That is the alkene family. So we have alkene family. Now, in the alkene family, what member of the alkene family contain 6 carbons? Contain 6 carbon atoms. That is the word hexene, right? Very good. So I'm going to change, or let me just bring this down and say hexene. So this is hexene. So you can either write it as hexene, because since the double bond is on carbon 1, you can write it as hexene, or you can decide to put a number just to indicate that the double bond is standing with the word, the first carbon. So you can write it as what? X1 in. Do you understand? This one means the double bond is placed on the what? First carbon, according to your numbering. Do you understand? So with this, we have been able to get the parent chain and the name of the parent chain through the right numbering close to the substituent available. Do you understand? So this is X1 in or Xn. Do you understand that now? And we have this substituent attached to it, but we're not going to talk about this until the next class. Till next time, have a good time.